In machine learning, we often want to build models that can accurately predict outcomes. But sometimes our models can become too complex and start to overfit the data, which can hurt the model's performance on new unseen data. This is where regularization comes in. The idea behind regularization is to add a penalty term to a loss function, which helps to control the model's complexity. The penalty term encourages the model to have smaller weights, which makes it less likely to overfit the data. There are two common types of regularization: L1 regularization and L2 regularization. Let's take a closer look at each of these. L1 regularization adds a penalty term proportional to the absolute value of the weights. This penalty term is also known as the L1 norm of the weights. The L1 norm of the weights creates a sparsity pattern where many of the weights are zero. This means that L1 regularization can be used for feature selection, where we can identify the most important features by looking at the non-zero weights. For example, let's say we are building a model to predict housing prices based on features such as the number of bedrooms, the size of the houses, and the location. Using L1 regularization, we can identify which features are most important and exclude the ones that don't contribute much to the prediction. L2 regularization adds a penalty term proportional to the square of the weights. This penalty term is also known as the L2 norm of the weights. The L2 norm of the weights encourages the model to have small weights overall but does not create a sparsity pattern like the L1 regularization. L2 regularization is commonly used when we don't have prior knowledge about which features are important. It can help prevent overfitting by keeping the weights small and reducing the model's complexity. Both L1 and L2 regularization can be tuned using a hyperparameter called lambda, which controls the trade off between fitting the training data and keeping the model simple. By adding regularization to a model, we can improve its performance on new unseen data and prevent overfitting. Thank you for watching.